Watka Nuarado Sewagoego. Greetings, everyone. Lindsay Young Steno Brant de Waxanazre, Gundeke Nini Wageno, Waganyato. Hello, my name is Lindsay Brant, and I'm from Gundeke, which is the place name for Tyendinaga Mohawk Territory, and I'm a member of the Turtle Clan here in Tyendinaga. I wanted to take a few moments to speak to you about land acknowledgements and what the importance is behind that and the meaning behind that. For myself, when I acknowledge land, I'm not only acknowledging the land and the peoples that are the caretakers of those lands, but also my connection to the earth itself, to my Mother Earth, and also to my connection to all of creation. And so I think I would encourage each of you to establish what your relationship is to the land and what your connection to the place that you're living in is. So what does it mean to you to be outside and experience nature in the way that I'm experiencing it right now? What do you feel and think and listen to or move through when you're outside? So it's important to think about those things and to think about the caretakers of these lands as well. Right now I'm on Mohawk territory, but just outside of this community and heading towards what is now known as Kingston, it was shared territory between many groups. So the Anishinaabe, the Haudenosaunee, and the Huron-Wendat people shared these lands. And so we give our greetings and thanks to them for taking on that role and that responsibility, and we recognize that they're the true caretakers of these lands. But we also think about what it means to share these lands and what it means to share all of us to share in connection in relationship with each other. So I really encourage you to think about that and what that means for you, and to explore and get out on the land as much as possible and really enjoy, cherish, and love these lands and take care of them, and they'll take care of you as well. Yawagoa, thank you very much.
Hello, everybody. So I'm Mark Richardson, and I have the honor today of introducing our speaker, my colleague here at Queen's and often partner in various outreach initiatives. So Connor Stone is about to complete his PhD studying the galaxy diversity in the universe. He has been Queen's Observatory Coordinator for the past 4 years, or is it 5? I have to admit that me and him talked about this and we actually can't remember. He's been doing it for so long. But through that, he's been running the monthly tours, and then with COVID, he's actually co-created the Fast Radio Burst podcast. So check that out if you haven't already. And Connor is notorious for going out of his way here at Queen's and beyond to make educational opportunities for his fellow students and the community, like he's doing today. Connor also does a bit of astrophotography as a hobby, although he swears he's not very good, but I would beg to differ. And so today we really do have the privilege to join Connor in celebrating the International Day of Astronomy. And so Connor, I welcome you to share your video and take it away.
Hi, Mark. Thank you for that introduction. Yeah, I need to sit down and count how long I've been the observatory coordinator. Yeah, also, thanks Linda, Pete, and Jason for making this happen. It's really fun to be able to share some of my love of astronomy with people. So I'm going to get started, and the way this will work is I'm going to share my screen while I use this program called Stellarium. And what the program allows anyone to do, it's free to download, it allows you to see what the night sky or what the sky looks like at any time or place around the world. It's super useful for learning a little bit about astronomy and planning what you're going to look at on a given night. So I'm going to go ahead and share my screen. And assuming that's working, Mark, I'm sure will chime in if it's not working. Assuming that's working, what you can see right now is a sunny sky. So Stellarium is a sky simulator, and it's currently daytime. So what you're seeing is a daytime sky. Now, you can see my mouse here, and I'm going to click and drag. And when I do so, you see that the scene moves around. So that's how I look around on the screen. I just click on a spot and drag around. If I keep dragging up, eventually there's the sun right there. And if I drag back down, we can see the horizon again. This is just a stock image of the ground. It's not anywhere in particular. So before we start looking around at all sorts of cool things in the sky, I'm going to walk you through a little bit of how to operate the Stellarium interface, and then we'll be able to know what's going on when we go around. So first up, I'll just turn that off. And on the side menu here, there's a bunch of different ways that you can interact with and control what's going on the screen. So this one right here, which looks like a clock, if I click on that, then a window pops up, and this window tells me the date and time that I'm looking at the sky for right now. So if I change, let's see, if I go, no, there we go. If I change the hour, which is currently 1:07, if I change that, now it's 2:07, we're using a 24-hour clock here. I keep going, you'll see the sky change a little bit. We're now at 4 o'clock, 5 o'clock, 6 o'clock. It's getting to be summertime, so it stays bright quite late now. 7 o'clock, oh, we're getting a little darker, and now the night sky starts to appear. Stellarium will simulate the effects of the atmosphere as well. So if we go even later into the night, we get an even brighter or clearer sky. If I go a little further, there we go. So we're now at 11 o'clock at night. And if I close that window, what we can see before us is the night sky filled with a whole bunch of stars. And if your screen is really good, you may even catch sight of a bit of the Milky Way here. Now, here we have a view of what the stars look like. This is sort of what you would see, minus these little labels here, which help you out to see what the names of the stars are. But this is pretty much what you would see. But this is a computer program, so we can add on more stuff. Here in the bottom, this sort of controls what you're seeing at the moment. And if I click here, the lines of the constellations appear up on the sky. I can also add the names of the constellations, and even, although it gets a little busy, there's art that has been included in the Stellarium program so that you can see what these constellations represent. I'm just going to turn that one off, but here we are in the night sky looking at the constellations, and that helps us sort of map out where we are in the night sky. Now there's more that we can do. Up at the top here, this cardinal direction location window, if I pull that one up, it brings us to a map of the Earth, and I can go anywhere on Earth and see what the night sky is going to look like there. Let's try jumping way over to Madagascar. So here I click on Madagascar, and if I close this window, you'll see it's not nighttime anymore. And that's because Madagascar is on the other side of the world, so the sun is still shining there partly. So when you change where you are in the world, it will change what you can see and what part of the night sky you can see. If you were looking really closely, you'll see that the constellations that I'm looking at have changed. And that's because I moved around. Here, this is the Lyra constellation that we were centered on before. And now it's even upside down because of course we're on the southern hemisphere. If I go back here and click up here, I can move back to Canada. And actually I can even just search. There's Kingston, Canada. That's where I am right now. If I click on that, then it'll bring us right back to where we were. So we can hop around the world. I like to sometimes use Stellarium to see what the night sky is going to look like when I go traveling. And then I can see if there's anything special that I want to look up while I'm traveling. Let's see, here I go. There we are again, but now it's the other way up. Vega's up on the top here. All right, so we've seen what the location window can do and what the date time window can do. There's lots of really neat stuff that Stellarium can do, and we'll get into some of the more advanced features later, but another feature that I want to showcase right now is the search window. So the search window, as you might imagine, lets you look up things that are in the night sky, and it'll bring your view directly to them. So let's try one right here, Vega. So that's a star, and we'll just type Vega, and it appears in the search prompt. If I just hit enter, then it brings us right centered on Vega and gives us all sorts of information about Vega. Now, I've been an astronomer for a little while now, and I have no idea what a lot of these numbers do. A few of them are really helpful though. First up, the type. It's a pulsating variable star. So that tells you what kind of star it is. It'll tell you something else if you're looking at a galaxy or a nebula or any number of other objects. The magnitude, that tells you how bright it is on the sky. And magnitudes are kind of weird, but you should know that smaller numbers mean brighter, bigger numbers mean fainter, harder to see. So it's almost, magnitude is almost a measure of how hard is something to see. Higher the number, harder it is to see. And there's a whole bunch of other information here that are useful for different scenarios, but for the most part, we won't really need to look at that. One that I like to point out, way down here, distance, it's about 25 light years from us. So this star, what we're seeing, the light from it has actually taken 25 years to get to us, which means that what we see when we look at that Vega star is the way that the star looked like 25 years ago, which is kind of crazy to me. And it gets much, much farther into the past when you look at other objects in the night sky. If I just give it a little right click, all that information goes away, and we're left with just our view on Vega. Now, if I use the scroll on my mouse, I can actually scroll in and zoom in on this star. Now, it's a star, so it's a point of light. No matter how much you zoom in, it's always just going to be a point. But there are other things in the night sky that you can zoom in on and see something more interesting. So now that we know a little bit about how to navigate the interface, how to move around on the sky, how to move around on the Earth and through time, there's lots of really, really neat things that we can do in order to see what's going on in the night sky. One that I wanted to showcase is called the double-double star. So if you're Canadian, you'll know what the double double is. And if I look up the double double star, so I type double double into the search window and I hit enter, you'll see the double double star. It's right beside Vega. So Vega is a nice bright star, easy to find in the night sky. This is what we're looking at right now is what the night sky will look like tonight, assuming that there's no clouds. It's never a cloudy day in Stellarium, which is very nice as an astronomer. So if I zoom in on the double double star, you'll get to see something really neat. Zooming in a little more. So these two bright stars right here, that's actually two stars orbiting each other. So this is a binary system. And what's really neat is you can actually see this just with a pair of binoculars, or if you have perfect eyes on a perfect night, you might be able to see a bit of separation and see those two stars. I suggest going with binoculars. Just about any pair will do. And you look for the double double star, which are two very bright, very close stars right next to Vega. And Vega is a pretty easy star to find. Now, I say that I've been looking at the night sky for quite a long time. If you want a bit of help, which actually secretly I use all the time, on your phone, you can actually get a version of Stellarium in such a way that you can hold it up, hold your phone up to the night sky, and it'll tell you what stars you're looking at right through the phone. It's a super cool feature, and that's actually how I do. That's how I do it all the time. So right next to Vega is the double double star. You zoom in by looking through some binoculars, and you'll get to see a system that's orbiting. And it takes thousands and thousands of years because these are so far apart from each other to go around. Whereas the Earth takes 1 year to go around the sun. This one will take thousands and thousands. But it's called the double double star. And the reason it's called the double double star is because each of these stars is actually itself two more stars, where if you zoom in further, if you get a telescope, let's see, will Stellarium show me? You can kind of see that it splits up into two. You need a telescope to really see it well. What about the other one? Let me zoom out here. If I zoom in there, there you go. You can see that it's two stars. It's kind of blurry. Stellarium isn't going to resolve it infinitely far, but you can totally see that there's two separate stars here. And that's what makes it the double double star. It's a double where each one of them is itself a double. And I think that's really fun. All these four stars are swirling around each other in this very complicated solar system, quite a bit different from our own. It's the same gravity, but very different results. The stars themselves are a bit heavier than our sun as well, so they're nice and bright. And that's why we can see them in the night sky. You can definitely pick them out by eye, but what you will see with your eye is one star. With binoculars, you'll see two stars. And then with the telescope, you'll see four stars. And some astronomers have done some fancy techniques to resolve it even further. And they were able to tell that there's actually 5 stars in the double double system, which I think is super cool. You can find it for yourself very easily in the night sky, even tonight. And you can tell your friends and family about this double double, very Canadian star. All right, so that's one thing that we can just find in the night sky if you know where to look. Another one that you can find, again, if you know where to look, I'm going to jump back down to the Southern Hemisphere again. This time, let's hop on over to Australia. It doesn't really matter so long as we're in the Southern Hemisphere. So now we're in Australia. And of course, it's daytime in Australia. Their time is backwards from ours, but that's okay. All I have to do is go to our date time window. I move time forward. Here we go. It's getting to be dawn or dusk. And there we go. So now it's nighttime down in Australia, down under. And if I look around, there's something that may not pop out right away, but if you look a little closer over here and over here, these two sort of smudges in the sky start to become visible. And if you're in Australia, these are actually visible to the naked eye so long as you're out somewhere dark. You can't see it if you're in the middle of a city, but if you go out a little further, you'll be able to see these for yourself, these sort of smudges here. And what they actually are is whole galaxies. These are galaxies with millions and millions of stars in them, even billions of stars. And let me pull it up nice and big. So this is the Large Magellanic Cloud, is what they call it, the LMC. And it's a galaxy, but it's a small galaxy by comparison to our own, the Milky Way. This one is actually orbiting around the Milky Way and will one day be absorbed into the Milky Way galaxy. I study galaxies, so I think this was super cool. And one of the really neat things that we've learned about galaxies is that they're kind of cannibalistic. They eat each other. And so our big Milky Way galaxy is going to eat this little galaxy in billions of years. It'll take a long time, but eventually it'll be sort of broken up and incorporated into the larger Milky Way galaxy. The same fate likely holds for the Small Magellanic Cloud down here. So I can zoom in on that one. Let me just keep going. There we go. So this is what it would look like probably through binoculars. And what you can see is all these little dots in here, thousands and thousands of dots. Some of them probably aren't even coming through on the zoom. And every single one of those is a star, and collectively they make up this big galaxy. Or, well, I guess it's a small galaxy compared to ours. So I think that's really neat. It's something that you can see just with your eyes, so long as you're in the right place, in the right time, and you know where to look. Now, unless you've been studying astronomy for a long time, you don't always know where to look. So I'm going to hop back over to Kingston, keep things more Kingston, Canada. All right. And it's now daytime because we were in Australia, 6 a.m. So I'm just going to go back a little bit. Now it's very late. This is 3 in the morning. Let's go to a more reasonable hour, say 11. All right. So here we are in the night sky. This is Kingston again. And we're looking at the view that we started with. So I mentioned, if you know where to look, there's some really cool things that you can find in the night sky. Now you know where to find the double star. And if you ever visit Australia, you know how to find the Magellanic Clouds. But there's lots of really, really neat things in the sky that aren't actually too hard to see. A pair of binoculars or a relatively cheap telescope, and you can get started. But of course, you need to know where to look. And the answer is the Messier objects. So this is a list pre-created. Messier, I like to think of it as like my bedroom. It's messy, eh? So when you want to find something interesting in the night sky that you can probably see just with a pair of binoculars or with a simple telescope, then what you can do is just type M and then a number in the search. So M, and let's go with 13. If I click that, that gives us a Messier object. Now Messier was trying to find comets back in his day, and these were annoying things that kept getting in his way when he was trying to find comets. But they turned out to be very useful for astronomers. They're excellent things to study because they're nice and bright. And what we're looking at here is actually a globular cluster. This is within our Milky Way, well, near our Milky Way galaxy. It's thousands and thousands of stars all packed in super, super tight to each other. Every dot you're seeing here is a star. And these are really useful for studying how stars evolve over time. So Messier accidentally gave us a list not of comets, but of very interesting things to study in astronomy. So you can find these things very easily in Stellarium just by typing M and then a number, and you'll see if it's up that night. Sometimes it'll be below the horizon, or it won't come up until really late in the night and you don't want to wait. So you'll have to just look around for another one. I actually, I like to do lots of astrophotography. I have my own periodic table of Messier objects. So there's just over 100 of them, and I've got a nice poster with all of them listed. There's really cool nebulae, galaxies, globular clusters, open clusters, super fun things to look at. And these are all sort of the brightest ones in the sky, easiest to find. So that is a super cool way to get started in astronomy. Now, let me say, okay. So that's a really great way to get into looking at the night sky, but not everything astronomy related happens at night. Now, some of you may know that in 2024, passing right through Kingston will be a total solar eclipse. And Stellarium can actually help us figure out if we are in the right place to see this thing. So in the location window, you can put in the location where you want to view the eclipse from. And then in the time window, you can actually accelerate not just till tonight, you can accelerate years ahead. So what we're gonna do is go to 2024, that's when the eclipse will be, and then April, and it'll be April 8th. There we go. So this is the day when the eclipse is gonna happen. And then we need to find the time. It'll happen during the day. Just give me a second. All right. So if you were looking really closely, you may have noticed it got a little darker. And what you'll see right there, I'm going to zoom in on the sun. Let's just center on that. So I'm going to zoom right in on the sun. And what you can see, the time that I've jumped to, I'm going to make it nice and big. The time that I've jumped to, we've got the sun right here, and the moon is partially blocking it. So if I go backwards in time, you can see the moon is sliding out and revealing the sun. So it's a 24-hour clock here. So what this is saying is 2:30 p.m. on April 8th, 2024. That's where the moon will be from our perspective at these exact coordinates. So we can look up exactly what it'll look like for us, exactly when to go out and see it. Now, if I go forward in time instead, so here we're going through, it's been about 15 minutes. Now it's been about half an hour from our starting point. You can see these eclipses occur kind of slowly. They take a couple hours to really happen. But the most interesting bit, the part that is most exciting when the moon completely covers the sun, that'll last generally for a few minutes, 3 or 4 minutes. That's pretty common. And that you do not want to miss. It's very special. So right at the moment when the moon covers the sun, you get to see this incredible view of the corona of the sun. The sort of, it's almost like the sun's atmosphere, although it is incredibly hot and not very hospitable like our atmosphere. You do not want to be near that corona, but it is quite pretty to see. And at the same time, stars will start to appear that you can actually see. So here's one right here. Stars will start to appear because the sun is blocked. It might as well be nighttime, not full nighttime, but pretty good. You'll be able to start to see, look, there's Jupiter there. So if you're in Kingston and you see the solar eclipse, you can look around the sky. And what's really neat, you'll be able to see Jupiter, you'll be able to see Venus, you'll even be able to see Saturn and Mars during the day, which is pretty cool. So that's kind of what the solar eclipse will look like. Oh, I gotta move back here. that's kind of what the solar eclipse will look like. It's very exciting. Here at Queen's, we're doing a lot of work to prepare for the solar eclipse. We've already started working on it, and we're really excited for what's going to happen. So you can see I moved ahead just a few minutes, and now the sun starts to appear. And even just a sliver of the sun is too bright, too bright. So everything would disappear from the night sky again. You won't be able to see it. So let's just hop back to today. So there we go. And we'll go back to tonight. And there we go. There we go. So now we're back at 11 on May 6th. So this is what it'll look like tonight. Oh, the moon's out tonight. Good to know. All right. So we've learned about the double star, how to hop around the world and see what sorts of astronomy sites will be out there, and of course the Messier objects, which are a great way to get started in astronomy. Just about everything I've taken a picture of is a Messier object. So doesn't matter what skill level you're at, they're always very interesting. All right. So what I wanted to...
Before we leave that, just as you brought up the Messier objects, there was a question about your periodic table.
Okay, yeah.
Wondering how other people can get one of those. Where did you find that?
I actually just Googled periodic table of Messier objects. Let me show you. Maybe Mark can enter it into the chat.
Yeah.
But the way that you spell Messier is, I think, French. So it's not the easiest one to spell. But if you get close, Google is really smart. They know what's up. And so if you just Google it, I downloaded the picture and printed it, and it's super cool. I've even for a while I had stickers on the ones that I had managed to find, and I was going to try and catch them all, kind of like Pokemon.
Very good. I found it and I
fun.
put it in the chat, so that's great. Thanks. Sorry about the interruption.
Perfect. Yeah, no. I want to get as many people interested in space as I can. When I was quite young, maybe 10 years old, I got a telescope, and I didn't know what to do with it. So I got it out, got it all set up, pointed it at Vega, I think. And I looked at it and was like, okay, that's blue. But it doesn't matter how powerful of a telescope you have, even Hubble will just see a blue dot when it looks at Vega. The Messier objects are really fun. Those are the things that you want to go and look up and see if you can get a better view of them. I've spent quite a bit of time holding my phone over my telescope and taking pictures of some of the brighter ones. So they're a lot of fun to learn about. Now, this whole time that I've been showing you the night sky, there's been these constellations up here. Now, these constellations are the ones that a lot of us would be most familiar with. They are sort of the Greek constellations that a lot of astronomers use. But there are actually constellations all around the world from different cultures. Stellarium has, especially recently, put in a lot of work to try to represent those in Stellarium. So what you can do, this is one of the more advanced features, which you'll find lots of really neat features just playing around with settings. And if I click on this one, Sky and Viewing Options window, there's a whole bunch of different ways that I can control the finer details of what I'm looking at. But this one right here caught my eye when I was just playing around. And this one actually shows us constellations from all around the world. So here we have Western constellations, and there's all sorts up here, but the ones that I've actually learned a little bit about are Ojibwe. And let me just close that so we can see. You'll see that now the Big Dipper here has a new name. it's Ojig, the fisher, or the Little Dipper is now the loon. Now, if I go down here, they've also included art provided by Ojibwe peoples that actually represents some of the story in this constellation. And the constellations do have some really neat stories into them. Before I get into any of that, though, I do want to do my own more astronomy-related land acknowledgement. So I'm going to do that here while you guys can see these really cool constellations up on the screen. Let me just maybe move it a little over and do that. All right. So to begin, yes, I've got it written down, so I like to get it right every time. To begin, let us acknowledge that Queen's University is situated on traditional Anishinaabe and Haudenosaunee territory. We are grateful to be able to live, learn, and play on these lands. In particular, we are gathered here today to celebrate our shared interest in astronomy, an interest that we share with all peoples around the world and through time. Since the first humans huddled around a campfire hundreds of thousands of years ago, we have looked up and been awed by the majesty of the night sky. Curiosity about the heavens is a connection that brings me closer to my ancestors and the peoples that lived with these lands before my ancestors arrived. As such, there are many bridges between astronomy as I know it and astronomy as practiced by those that came before me. We are all familiar with the Big Dipper, but to the Anishinaabe is known as the Fisher or Ojig. The Pleiades is known as the Hole in the Sky or Bagongazig, the Seven Sisters or Subaru. It has names all around the world. Polaris is called the Dog Star. By a different name, they are all the same stars. So in these uncertain times when we often must stay apart, let us remember the things that bring us together under the same stars. And so with that, I'd like to encourage you to use some of these really neat features in Stellarium to learn more about the night sky as viewed from people all around the world and through different times. Ojig the Fisher, in particular, is actually a notable character in many different cultures, Ojibwe, Anishinaabe, Haudenosaunee, and the Innu peoples. There's lots that recognize the Fisher. And his story, you can see that there's an arrow in his tail where he was pinned up into the night sky. He actually rescues people and the animals and all of nature really from a really long winter. And in fact, this story, which was passed down through oral tradition, can be traced back to the last ice age, where it would have been a really long winter. And the story about it obviously would have a big impact and a big place in the night sky. And it's connected to the Big Dipper. But in the story, he manages to free the birds and return spring to the land after this very, very long winter that would have been a whole ice age. So I'm not going to share the whole story. I don't think it's my place to do so, but there are people who have shared these stories. There's going to be links, I think, in the online program at Science Rendezvous. And you can also look up nativeskywatchers.com. There's several different people that have sort of shared these stories with us, and they're super cool. I've watched a bunch of them. It's really neat what they have in these stories. Now, as you could have seen on that list, it's not just Ojibwe here. There's all sorts of different cultures, and they're working on adding in art. So they don't have art for all of them yet, but they have it for quite a few. Some that I picked out that I thought were really neat. There's Arabic, And let me just close this. So there's obviously a story connected with every one of these, and I'd be really curious to learn all of these stories. I've recently read the book or listened to the book through Audible, Mythos, which goes over a lot of the Greek stories. I thought that was really fun. There's Dakota. So this one, here we go. You can see that there's very distinct art styles for each of these. And a lot of the constellations are actually, like it's a similar set of stars because people have recognized these from all around the world independently. This is what we would call the Big Dipper, but they would call it the Blue Woman. Here, there's the Thunderbird. The Thunderbird is a very common character in a lot of indigenous cultures around North America. So there's lots of really neat stories connected to these. There was another one, Vanuatu, that one. What I thought was interesting about this one is I click on that and there's nothing here, but that's because they're from the Southern Hemisphere. So you'd have to be in the Southern Hemisphere to see it. I'm gonna cheat a little bit because this is Stellarium and it's just a computer. I can actually turn off the ground. And when I turn off the ground, I can now look down into what the sky would be in the Southern Hemisphere. And look at this. This is what I would call the Southern Cross, but for the Vanuatu, it's the Four Roads. And there's some really neat art connected with these constellations. So definitely play around with Stellarium, have some fun learning about all of these different ways that people have looked at the night sky. There's some really neat stories in there. I'm going to switch back to the Western ones because that does give me, oh wait, actually, before I go any further, I'm going to tell you one more, the Hawaiian Starlines. So for the Hawaiian Starlines, here we go. I'm gonna, it's kind of hard to get it all. The Hawaiian Starlines are actually really kind of special constellations because they're gigantic. They're so big, you can't even see the whole thing in one night. Now, what you're looking at the end here, that's Polaris. Polaris is really useful because it doesn't move through the night. It stays fixed. It's a fixed point. And actually what's really useful about that is depending on what latitude you are on Earth, Polaris appears at a different height in the sky relative to the horizon. So let me just, sorry here. So this distance here won't change through the night. If I just go through time, you can see over a whole day, Polaris stays in the same spot. So that height off the ground tells you your latitude. So it's a great way to help you navigate. You need to know your latitude and your longitude. And with that one star, the Hawaiians would be able to know one of those two coordinates instantly. But sometimes it's cloudy. And if you go far enough south, you can't see it anymore. So these incredible starline constellations, which trace all the way from the north to the south of the sky, these constellations, if you could have a map of them in your mind, all you would need to see is a couple stars, and you'd be able to mentally figure out what your latitude is. If you are a very, very experienced sailor, that is. And the Hawaiians were able to do this. They were able to navigate using the night sky, and the way they did it was by knowing the shape of these constellations so well that all they needed to see was a couple of the stars, even on a kind of cloudy night, and they could reconstruct the whole thing in their mind and figure out what the latitude was. I think that's pretty incredible. And of course, there's even more involved, but I'm not going to go any further in that. That's something to look up and get excited about astronomy with. So I'm going to go back to the Western constellations because those are the ones that I often use as my reference points. I'm going to turn off the art because that covers the whole sky. So yes, I think that's a really cool thing. I like to show it in all of my presentations using Stellarium because it's such a neat feature. But there's a lot of really neat features in Stellarium that also connect to some more modern scientific work that's only recently been done. And one of the really cool things that's super easy in Stellarium to turn on, if I go down here, again, this panel here sort of shows what's visible right now. So right here, I can turn on what's called deep sky objects. Each one of these little highlights is a nebula or galaxy or cluster that might be interesting to look up. Now, some of them are really hard to see. You'd need quite a special telescope. You'd need to take pictures and stack them on top of each other. But other ones, like this one right here, that's the Messier 13, the Messier object that we looked at. So these can sometimes help you see what's visible in the night sky. Just keep in mind that not all of these ones will be as easy to see as the Messier objects. I'm going to turn that off because that's a lot of things on the screen. These control a little more of your artificial telescope setup because it's simulating a telescope view. And then right here, this button turns on exoplanets. So each one of these green dots is a star where we have discovered an exoplanet around it. An exoplanet is a planet like some of the planets in our solar system, but around a different star than our own. Each one of these green dots, we know for sure there's a planet there, and they have all sorts of different types. Now, right next to Vega, if I zoom in, you'll see all of a sudden thousands and thousands of these things appear all in this same clustered spot. And that's not because there's extra planets there. That's because there was a very special telescope program called Kepler, which actually stared at this patch of the sky for a really, really long time, watching every star very, very closely, because every now and then, a planet that was orbiting that star might pass between the telescope, the Kepler telescope, and that star. And when it does that, just like the eclipse we saw earlier, it dims that star, makes it fainter. And so Kepler spent years watching just this patch of the sky for when the stars would get just a little bit dimmer. It's not quite as dramatic as the eclipse that we saw, but they would get a little bit dimmer and then a little bit brighter, back to normal. And when they did that, Kepler could say, there's probably a planet there. And it would keep watching until it happened again. And now it's very sure that there's a planet around there. And it's done this for all of the stars in here, at least as many as it could. So it was able to discover tons and tons of planets there. The place that they chose on the sky right here, it's not particularly special. They knew that the conditions here were really good. It's very faint to see, but the Milky Way is just running down here. They didn't want to point right into the Milky Way because then there would be too many stars and it would overload the camera. And they didn't want to point way up here because you're looking out of our galaxy and there's not as many stars in that direction. There's tons for us to see with our eyes because they're nice and close. But for a telescope where every little inch that you look at on the sky has thousands and thousands of stars, this was sort of the happy medium, not too many and not too few stars, where they could get the most out of the time with that telescope. So let me scroll back here. There's been exoplanets discovered all around the night sky, and they've been discovered in all sorts of different techniques, but lately the biggest one is what that Kepler telescope does, looking for the planets getting a little bit dimmer. All right, so I'm just gonna check, how are we doing for time here? We've got a bit of time. So a couple final things that I'll do before we end the sort of first session here. I'm going to show you something that astronomers would really like to do, which is have the ability to just turn off the atmosphere. In Stellarium, you can do this. You can turn off the atmosphere, and I hope it comes through clearly, but the Milky Way just sort of pops out along the sky here. When you turn off the atmosphere, it suddenly becomes much easier to see. This is sort of how things look like to a space telescope. But down on Earth, we have the atmosphere. We have the atmosphere, and because of that, it actually scatters light from nearby towns. You can see an example over here, just as part of Stellarium helping us out, or from the sun, light can get bent around. Lots of things can sort of add to how the atmosphere blurs the light that we see. But it does depend very much on where you are. So again, we can go to these extra features here on the sky. I'm going to show you, this is a light pollution level 2. If we go to a light pollution level 1, things become much clearer. Let's see. Yeah, let's just turn off the ground for now. So that'll make it easier. There's the moon. There's the Milky Way. So now you can see the Milky Way here. So at atmosphere light pollution level 1, that's sort of, if you drive like an hour north of Kingston, there's a great spot called the Dark Sky Site, and this is sort of closer to the view that you'll see. Now, as we go up in the scale, light pollution level 2, you can still mostly see everything, but it's not quite as vibrant. And you go 3, 4, 5. Now we're pretty much in like a large town. 7, 8. Now we're kind of in like a city. And you see that the night sky kind of disappears from our view. So something I like to tell people is if you want to get engaged in your community and do something for astronomers, you can help work on the light pollution. There's actually dark sky bylaws that can be passed in different counties. And what they do is basically make sure that any lighting that you have in the town, like say Kingston, any lighting is only facing down, lighting up the ground and not the sky, because this is what it looks like otherwise. And if we take it away, we get the night sky back. And I think that looks really cool. I quite like looking at the night sky. Anyway, yeah, I mean, you can picture that. All right, one other thing. Here we go, we've still got a bit of time. So up on our special viewing area, we've got the star lore, which we were looking at earlier, but we've also got surveys. So a lot of astronomy surveys that are used for research, that I use in my research, are actually listed in Stellarium, and Stellarium can load in this data that has been taken by these super advanced telescopes. And because the data comes with coordinates, Stellarium can actually put those images up on the sky for us. So there's all sorts of them here. These are all different surveys that astronomers have done to look at the night sky, and Stellarium can put them up there for you. I'm going to go straight to one that I've used in my research. I'm hoping to publish a paper soon using this data right here. It's called Unwise, because astronomers are funny. And if I click on that, the night sky completely changes. It looks very different than it did before. And that's because what we're looking at is the night sky, but seen through an infrared camera. Here we go. And if I zoom way in, what you can see is all of these incredible dust clouds in this region here, which is actually this bright area here. That's a star forming region. New baby stars are being made here. Baby stars that may only be a few million years old. which is very young for astronomy stars. And you can see all this incredible dust, and it looks really pretty, but as an astronomer, it gets in my way a lot. So I try to avoid regions like this that have a whole lot going on when I do my analysis of galaxies, and the galaxies that are way out. They would be behind all of this dust that we can see, but still I can appreciate the beauty. I mean, look at that. And you can definitely check it out for yourself. Of course, this is just one of the surveys that is up in Stellarium, ready for you to just click on and take a look at. Some of them are kind of underwhelming, but others are really spectacular, like this one. So I'm going to turn that off, and we go back to, this is the regular view that we would see with our eyes. And as you can see, this is still very pretty to our view, but there's a lot that we're missing. Our eyes don't see a lot of the dust that's going on. We see it right here where it's lit up by these brand new, young, energetic stars. We can see the gases sort of as a shadow almost, and see some of the areas here that are lit up because they're being bumped up in energy by these incredibly bright stars. But the area around them is a lot less clear than it is from a different wavelength with a different set of eyes. And astronomers have used everything from gamma rays, X-rays, ultraviolet, visible light, infrared, radio waves. We've used it all to look at the night sky and learn all sorts of really neat insights about how the universe works. So I think that's a good place to leave it. We might be just a little bit early, but that just means more time for questions. So I'm going to leave it there and let Mark sort of take over the hosting again.
Great. Where's I have a list of a number of questions have come in, and I want to encourage more. Ideally, if you can use the chat feature, that would be great, but there is also the Q&A feature, but I'm trying to focus on the chat. Yeah, so thanks for a great session, Connor. I think Stellarium is such an interesting tool, and there's so much power there, and you know, you've just given us a taste, and so I hope that everybody at home gets to kind of dive into that a little bit more. I do want to highlight that you're actually about to be leaving us. I'm getting sad. You're going to be moving, I think, over the summer to start a new research position at the University of Montreal, where he will be studying strong gravitational lensing with machine learning. So using machines and computers to try to find, I think, these distant galaxies, understanding this feature of gravitational lensing. And I wanted to highlight too that both Connor and I will be at Science Rendezvous tomorrow. So feel free to maybe pop by and say hello. I think there's going to be some different ways that people can look through maybe a solar telescope or whatnot, among many, many other things. So yeah, thanks again, Connor. And like I said, there has been a number of questions throughout the presentation. I see that more are coming in now. The first was, and this is actually, I feel, after your presentation, a bit of a trick question. So Lola asked how many constellations there are. And I'm wondering if you might want to weigh in on that, and if it actually matters which culture you're kind of asking the question of.
Yeah, so that's obviously a very complicated question to answer. I'm going to do something cool with Stellarium here. I've turned off the ground, and I've turned on the constellations. And if I zoom out, because it's a computer and it can do whatever it likes, I've zoomed out all the way here. You can see the whole night sky with all of these constellations shown. This is a lot of constellations, and this is only the beginning. These are the Greek ones. They're every culture all around the world, all through time, has mapped out the night sky, because of course this is sort of a shared heritage for everyone. So this is over, I think, 100 constellations for one culture. It's somewhere around 100 constellations, and that's one culture at one point in time. The actual number, if you wanted to ask everyone to list all of their constellations all around the world, I'm pretty sure that you would never be able to get them all. And each one of them has a really neat story behind it. For the let's see, Leo, there, not Leo. Where's Canis? Canis Major and Canis Minor. I'm not seeing it. Oh, there it is, Canis Minor. Like these two have an interconnected story where one of them is like a fox that can never be caught in Greek mythology, and one of them is a dog that always catches what it's been set after. And in the story, the dog gets set after the fox, and this one can't be caught, and this one has to catch something. It's a logical paradox, so they're circling around each other forever, and it makes Zeus angry. So he just puts them up in the sky to circle around each other forever. And that's just one story. There's so many stories out there. And a lot of them are really fun. The Greeks liked to play with paradoxes, but each culture had their own thing that they liked to focus on. Like I mentioned in the Ojibwe one, they kept track of an ice age with one of their stories.
Does Stellarium allow you to do the stencil, like the edge between the constellations?
It does. So one of the ways that astronomers map out the night sky is by saying what constellation a object is in, or a star is in. And the way that we decide whether it's in or out of a constellation is these lines. So anything inside this box here would be in sextans. And these boxes are kind of weird. Some of them have funny shapes, but that's one of the ways that astronomers can tell where something is in the night sky.
So odd. All right, we had another question from Francois. Are M13's cluster stars, which you showed for us for a bit, are they orbiting something? Is there something at the center similar maybe to how Sag A star, the center of the Milky Way, is doing, or something else going on there?
Great question. So let's zoom on in. I'll pull it up here. So there we go. We get a nice view of M13, the great cluster in Hercules. And the question of whether or not it's circulating around something in the center, most likely there is a black hole or a cluster of black holes at the center. But just like with our galaxy, although there's a black hole at the center, that's not really what they're circulating around. If you pulled out the black hole, it wouldn't change too much. Most of the mass here is in all of these stars collectively together. So in our solar system, everything's orbiting around the sun, because the sun is like 99% of all the mass in our solar system. But it's a little different here. All the stars collectively have much more mass than the black hole at the center would. And so they're really orbiting around each other, their collective gravity. Although there is likely a black hole at the center, just because some of these stars would have formed black holes. And a little trick about how gravity works, a black hole will work its way towards the center of a gravity field like this over time by kicking other stars out. So actually there used to be more stars in here, but that's a whole other conversation. That's the dynamical evolution and lots more stuff. Mark would actually be really good at explaining that, because he works with simulations and they do this kind of stuff.
Yeah, I don't have patience to stare at a telescope for millions of years. I just don't have time for that. So I use computers to do the work for me. Actually, I'm wondering, before we go on to some more questions for you, Connor, I want to bring Linda on, if she could actually share her screen to showcase a little bit about the expo.
Sure. So I can just stop sharing my screen then?
Yeah, and we'll bring you back in a moment.
Connor, thank you very much. The reason I am doing this is because a number of people have asked about your presentation, and a number of people have asked about the various cultures. So what I would like to do right now And I'm hoping that everyone can see that screen. Can you?
Yeah.
So this is the complementary piece to Science Rendezvous. We have webinars happening over the next few weeks. Our live event is tomorrow at Leon Center, where there will be activities outside on Tragically Hip Way and King Street. And then we also have all of these resources that are basically for what we call STEM on demand. Now, over here, you see May 6th celebrate the International Day of Astronomy. Early next week, we will upload the recording of today's webinar onto that button. And when you click on it, you will be able to actually replay today's webinar at any time that is convenient for you. Connor mentioned that we have a very special resource called Haudenosaunee Star Stories. And basically, Connor has worked with Jason Pind, who is a postdoctoral fellow at the Faculty of Education, to help us understand something called two-eyed seeing, which means out of one eye, we see the world through our own background, and through the other eye, we see the world through our Indigenous cultures. Jason will explain what two-eyed seeing is all about and what he has learned about it. And he will then present some of his own Indigenous sky stories. You will also hear from Lindsay Marie Brandt and Liv Radeau. You heard from Lindsay at the beginning of this webinar, and they will share the star stories that were told to them by their elders. If you go to this button, Navigating the Night Sky, you will see that the Royal Astronomical Society of Kingston branch has entered for you a number of, oops, I clicked out too quickly, a number of recordings and materials to expand your knowledge of the night sky and how to become an astronomer like Connor. Thank you for the opportunity to basically share that information about Science Rendezvous and about the fact that we will have the recording for everyone to see. And now, Connor, I'll turn it back to Mark. Thank you.
Thanks, Linda. It's just such an amazing lineup. I'm very excited to get to dig into some of that myself. So thanks for all the work that you and the group has done in developing that set of opportunities. And this one. And Connor, again, I want to thank you for the time you spent with us. So I do have a few other questions or comments. I wanted to highlight something for you live here on the air, just so that you can hear it. Dr. Donna Coleman, wanted to share that, Connor, this presentation is brilliant. Thank you. I particularly appreciate your reference to the southern sky, with which I'm very familiar because I've been a member of the Astronomical Society of Victoria in Australia for many years. Also, the references to Native American and other cultures' sky lore are wonderful. Thank you for a very informative session, and keep looking up. Thought I would share that with you. But another question.
You,
really, really appreciate you sharing that kind of appreciation for this event. A question from JM says, how many planets were found by the Kepler telescope?
That's a good question. So the exact number changes with time because astronomers keep reanalyzing the data. And as they get more confident in their ability to find these, they can actually find fainter and fainter signals where there's a star. So the exact number changes with time, but it's in the ballpark of around 4,000, if I recall correctly. So it's a lot of planets. It's a lot of solar systems out there, and it's a lot of fingers crossed, other Earths, other people that are also looking up at the sky and seeing us.
I think to put some things into context, I think before Kepler, there were only maybe in the hundreds of known exoplanets, maybe less.
It would have been high hundreds. But yeah, Kepler has blown away everything after it. You're right. Yeah.
Then even since Kepler, there's now the TESS Space Telescope, which is doing very similar work, but finding, that mission's still ongoing. And so
TESS is super cool because it's looking at smaller stars than our sun. It's not looking for Earth-like planets around sun-like stars. It's looking for planets around much smaller stars, which might actually be what's called a super habitable planet. And I love this concept because these stars, which are smaller than our sun, actually live a lot longer than our sun. And so one might be able to find a planet that's habitable, but will last for trillions of years instead of our sun, which will be done in a couple billion years. So I think that's super cool.
Wow.
Yet to be found, though. We'll see how it goes.
There was a question when you were talking about the eclipse. What cities besides Kingston are on the path of totality? Is there a way maybe that people can find out?
Yes.
They're
So
on the path of totality.
The best way, I think, is timeanddate.com. And let me see, time and date 2024. Let me just pull this up quick. Here we go. I'll share my screen. And so this is timeanddate.com. This is the one that I use. And they have all sorts of different things listed, but what you can see right here is a map of the globe and the track that the eclipse is going to pass through. So that track goes right through Mexico, the States, and a bit of Canada. There's another way to look at it here. Now, the center line, the darkest line, that's where you get a total eclipse. Everything that's kind of shaded means that you'll get a partial eclipse. So the moon will kind of glance by the sun, but it won't block it completely. If you want to see it blocked completely, you've got to be right along here. There's an animation of it. It'll tell you the exact times to look at. So lots of great information here on timeanddate.com. I've zoomed in on this, and Toronto will be missed, but Kingston will get to see it. So if you...
I think, and not just Toronto, Ottawa, Montreal, they're all missed.
They're all missed, okay.
Hamilton, Kingston, they do get it. Sherbrooke, somebody in the chat did highlight that Sherbrooke does get it. Well, it looks like Montreal does.
I think Montreal just gets it. You can see Toronto just misses it.
Yeah.
Chatham gets it. Maybe if you're on one side of Chatham, you'll get it. So
Vancouver does not get anywhere close. Somebody asked in the chat about Vancouver, and I don't think they might not even qualify as a partial eclipse.
Vancouver won't. So Vancouver might get to see, like, just during sunset, they'll see the sliver of the moon kind of thing. They won't get to see it very well. You'll have to travel a bit. But eclipses happen somewhere on the world, roughly every other year or so. So if you really want to see an eclipse, you can go eclipse hunting, travel around the world. But yeah, one thing I want to note is the closer you are to the center of the band, the longer the eclipse you get, the better the eclipse. And Kingston is actually pretty deep into it. So we're going to get a good eclipse. Montreal will get a shorter eclipse.
Mm-hmm. Yeah, Sherbrooke looks like they'll have a great one. I think we have like 3 minutes of totality here or so.
No, they're all busy on the phone. That's
sorry. So the next question that I see in the chat, actually it's more of a comment, is Roger highlighted that he found it very interesting that the different cultures seem to all have made kind of stories or featured on the same kind of star clusters. And just, I think he commented on that, but I think it is kind of interesting, especially when I think when you took off like all the light pollution, to me, like the stars just all become like a uniform cloud. Like I'm surprised that people did seem to consistently focus on the same star features.
Yeah, so that surprised me too, because like I grew up way way out in the middle of nowhere, and so I got night skies like you're supposed to see them, and the the sky really is totally blanketed with stars. But definitely some of them really stand out. The Big Dipper, you can't miss no matter what situation you're in, except possibly on the top of Mauna Kea when it's even more stars filling up the night sky. If you go to Hawaii, definitely go up Mauna Kea and get a look at the night sky if you can, because it's really beautiful. But a lot of the ones that I focused on, like the Big Dipper, the Little Dipper, or one that I often look at is Orion. These ones are, among all the bright stars, especially bright. And so I think the connection is perhaps a bit artificial and my fault, because I'm focusing on these really bright, easy to find ones. When you get to a lot of the other constellations, it's all over. It's just some of these bright ones that are really bright and distinct. Those ones stand out no matter who you are.
That makes sense. I think the last question that I see in the chat, and by all means, people can still enter more questions, is do you have a sense of just how many stars are in, I think it was M13 that you showed? Yeah.
M13, yeah. Good question. So the number of stars, it will be thousands, maybe tens of thousands. I can quickly look that up. The Great Cluster in Hercules. So I can rarely keep track of all of these
Yay for
numbers.
Technology. It puts all this information at our fingertips.
Yeah, so I can rarely keep track of these kinds of numbers in my head, but luckily, like M13 is so popular, it even has its own Wikipedia page. So if I go around and look for some numbers, let's see. It's 145 light years in diameter. So from one side to the other, they're looking at each other 145 years in the past. Well, let's see, there we go. Its mass, the total mass there is about 600,000 times the mass of our sun. So if our sun is a average mass star, then it's not exact, but there's somewhere around 600,000 stars all packed in there. So the night sky, like the brightest stars that we see, their sky would be packed full of stars like that. It would be truly, like if we had an Earth in a globular cluster, it would be truly incredible, their night sky. Probably so much so that it would be hard for them to do astronomy. It'd be really pretty, but it'd be hard to do hard to look at some of the fainter things. So someone should really simulate what a night sky would look like on a planet in a globular cluster. But yeah, somewhere,
that's a really good idea.
Somewhere in the a few 100,000 stars would be a reasonable ballpark for where it's at. I don't think anyone has sat down and counted them all.
Of course not. Yeah. All right, Connor, I think with that, we're going to wrap up. I really want to thank you again for your time. I want to remind everybody, we're going to have solar telescopes. We're going to have a planet walk. We're going to have see a comet get made. We're going to have a number of other displays outside and inside. So there's lots of different ways that I hope that you can engage with us tomorrow. Have a great rest of your day and enjoy all of Science Rendezvous. Take care, Kingston, and everybody else.
Thank you. Bye.
Bye.
Connor, thank you. That was wonderful. The feedback in here, we'll send you the chat, has been extraordinarily positive. And as always, we've learned some more. So that's what it's all about. And we're so grateful that Mother Nature is going to be with us tomorrow for a good day after we had to cancel on Wednesday. So everything looks great.
That's good,
Everything
yeah.
looks great. Okay, we'll see you tomorrow. I'm heading down to Leon's now to finish setting up tables and to make sure everybody's happy with the space they got. Some people are loading in today. We wanted to stagger it so that it wasn't too chaotic tomorrow morning. And we're just grateful that the Frontenacs did not have to play tonight, or else it would have been chaos in the morning. So we go
Yeah.
from there.
But
Okay.
let's say go fronts, though.
You know what? We have to say great work. You guys, you're doing a fabulous job. But why did this have to go on so long? Okay, we'll see you tomorrow. Bye-bye.
Yeah, bye.
Bye.